The importance of purlins is purlins allow you to securely fasten roof and wall cladding sheets to any structure. By placing purlins, you establish a framework that bears the weight of the metal sheeting and applies this pressure to the building structure, resulting in a stable and steady construction for many years. Hi, I'm Julian Leonard Pineda, and I'm going to solve two analysis problems about purlins. Without further ado, let's start. Para sa problem number 1, here are the givens. Slope is equals to 1 unit vertical, 4 unit horizontal. Distance between trusses is equals to 6 meter. Spacing is equals to 1.2 meter. Dead load is equals to 720 Pascal. Live load is equals to 1000 Pascal. Wind load is equals to 1440 Pascal. Windward coefficient is equals to 0.2. Leeward coefficient is equals to 0.6. Assume all loads pass through centroids. Properties of C200 times 76 mm. Sx is equals to 6.19 times 10 raised to the 4th cubic millimeter. Sy is equals to 1.38 times 10 raised to the 4th power cubic millimeter. The weight of the purlins is equal to 79 Newton per meter. Allowable bending stress is given. It is Fbx is equals to Fby is equals to 207 MPa. The required are bending stress of major axis for dead load and live load combination. Bending stress at minor axis for dead load plus live load combination. And number 3 is max ratio of actual to allowable bending stress for 0.75 dead load plus live load plus wind load. Since given yung 1 unit vertical and 4 units horizontal, para makuha ang angle of inclination, gagamit tayo ng Pythagorean theorem. Na nga, c squared is equals to a squared plus b squared. So, nakuha natin yung value ng c, which is the hypotenuse, which is square root of 17. For the distribution of load, kuhanin muna natin yung p. So, for the normal, yung 1,720 na yan, yun yung dead load plus live load. Then yung 4 square root of 17, 4 over square root of 17, siya yung sa angle. So, ganoon din yung 1 is equal to over square root of 17. Yung 1 yung sa vertical and 4 sa horizontal. For the normal, ang nakuha natin is 1,668.645 Pascal. At sa tangential naman ay 417.161 Pascal. For the distribution of loads, ang formula is delta is equals to P times X, which is yung P nakuha na natin kanina sa normal and tangential, and S yun yung spacings, which is 1.2. So W is equals to P times S is nakuha natin sa normal is 2002.374 Newton per meter, at sa tangential naman ay 500.593 Newton per meter. For the weight of purlins naman, since ang weight of purlins na sinabi kanina ay 79 Newton per meter. Kaya, ita-times lang natin yon sa 4 over square root of 17 pag sa normal, at sa tangential naman is 1 over square root of 17. So, nakuha natin dyan is 76.641 Newton per meter and 19.16 Newton per meter naman sa tangential. So, kukuhanin natin yung mga loads na dead load plus live loads saka weight of purlins kasi sila yung mga loads na tinatawag na gravity loads. Sa normal, pag kinuha natin yon is 2002.374 plus 76.641 is equals to 2079.015 Newton per meter. Sa tangential naman is 500.593 plus 19.16 is equals to 519.753. Ang next thing naman na kukuhanin natin is max moment. Sa max moment naman ay formula ay mx is equals to wl squared over 8. Nababago yung over 8 na yan, pero depende yun sa sagrad. Pwedeng ba maging 8, maging 32, ganon, 90. Pero since sa problem na to walang sagrad, so gagamit natin is over 8. Okay. The max moment mx is equals to wl squared over 8, which is yung nakuha natin kanina is sa normal is 79.015 times 6 squared over 8. Yung 6, yun yung length ng isang span. MX ang takuha natin dyan is 9,355.568. And sa MY naman is 519.73 times 6 squared over 8. At ang nakuha natin dyan ay 2,338.889 Newton meter. Para naman sa pagkuha ng max stress, F is equals to M over S, which yung S, yung SX and SY, makukuha natin yon sa properties ng C purlins. And yung M, yun na-solve natin sa max moment. Para makuha natin yung max stress, Fx is equals to 9 sa normal, o tinatawag din natin na major or x-axis bending, is 9,355.568 times yung 6.19 times 10 raised to 4. At 1.38 times 10 raised to 4 naman ang gagamitin na S sa tangential. So, ang nakuha natin dyan is 151.14 sa major axis at sa minor axis naman is 169.85. For the computation ng number 3, this is we're going to do 0.75 daw ng dead load plus live load plus wind load we can consider. So, the windward side shall be considered kasi nandun yung mabigat na part. Pagdating kasi sa leeward side, nagka-contribute pa yung windward side para makabawas ng loads niya. Kaya mas consider natin yung sa windward side. So, ito, for the normal, 1,440 Pascal, yun yung wind load, times 0.2, which is 288 Pascal. 0.2 is the windward coefficient. 288 Pascal times the spacing na 1.2 meter is equal to 345.6 Newton per meter rather. And then 2079.015, which is yung load, dead load plus live load plus the weight of the purlins plus 345.6 Newton per meter is equals to 24.615 Newton per meter. The sinabi, 0.75 daw percent ng dead load plus live load plus wind load. Kaya makukuha natin dyan is 18.461 Newton per meter. Pag naman sa tangential, 0.75 times 519.753 is equals to 389.815 Newton per meter. Ganun din, kuha natin yung max moment. Yun nga, 8183.0.75. At sa MY naman is 1754.168. Kuha din natin yung max stress na 132. Nga nakuha ko, 132.198 megapascal. And FY is 127.114 megapascal. Ito na. Yung interactive value, yun yung IB is equals to f of x over fpx plus fy over fpy, which is should be less than or equal to 1. Pag kasi sumobra siya sa 1, ibig sabihin nun, hindi siya safe. So, compute natin, 132.198 over 207. Yung 207 na yun yung allowable bending stress na given kanina. Yun yung fpx and fpy. So, 132.198 over 207 plus 127.114 over 207 should be less than or equal to 1. But ang nakuha natin is 1.253, which is greater to 1. Therefore, ang purlins natin is not safe. For the problem number 2, here are the givens. Length is equals to 4 meter. P times T is equals to 100 mm times 150 mm. Spacing is equal to 0.6. Weight of the rope is 120 PA. Weight of purlins is 5.5 kilonewton per meter per cubic meter. E is equals to 70,300 MPa. Coefficient is equals to 0.8. Live load is equals to 750 PA. Ceiling load is equals to 140 Pascal. And B is equals to 200 kPa. Required, determine the maximum bending shear stress of the purlins. Since hindi given yung angle of inclination, gagamit tayo ng formula na P is equals to 0.0000 per 173 times B squared. So B is equals to 200 kph. So 0.0000473 times 200 squared is equals to 1.892 kPa. Tapos ita-times pa natin yung sa coefficient na 0.8, which is 1.514 kPa. For the normal, P normal is equals to 2p sine theta 1 plus sine squared theta. Para makuha natin theta, nakuha natin na tan theta is equals to 1 half. So, ang theta natin is 26.6 squared. 26.6 degree rather. So, P normal is equals to 2 times 1.514 sine 26.6 divided by 1 plus sine squared 26.6. At ang P normal natin dyan is 1.129 kPa. For the live load is equals to 750 times 0.536. At nakuha natin live load is 402 Newton per meter. For the weight of group, 120 times 0.6 is equals to 72 Newton per meter. For the weight of purlins is equals to 0.1 times 0.15 times 5,500 is equals to 82.5. Yung 5,500, yun yung weight of purlins. Ceiling load is equals to 140 times 0.536 is equals to 75.04 Newton per meter. Wind load is equals to 1,129 times 0.6 is equals to 777.4 Newton per meter. The total vertical load is yun nga yung dead load plus live load plus the weight of purlins. So, 402 plus 72 plus 82.5 plus 75.04. Yung 75.04 is ceiling load, which is yun din, vertical load din siya. Kaya ito equals sa 631.54 Newton per meter. For the normal, we're gonna solve it with the formula Wn is equals to WL plus total vertical loads cosine theta. Wn is equals to 677.4 Newton per meter plus 631.54 Newton meter times cosine 26.6. And the normal weight is 1,242.094 Newton per meter. Tangential is equals to total vertical load times sine theta. So 631.54 sine 26.6 is equals to the tangential weight is 282.778 Newton per meter. For the computation of max moment, mx is equals to WL squared over 8. mx is equals to 1,242.094 times 4 squared over 8. mx is equals to 2,484.188 nm. So, for the my is equals to WL squared over 8. My is equals to 282.778 times 4 squared over 8. My is equals to 565.556 Newton meter. For the FBX is equals to 6 times 2484.188 yung mx times 100 times 150 squared. Yun yung dimension ng C purlins. FPX is equals to 6.625 MPa. FPY is equals to 6 times 565.556 over 100 squared times 150. FBY is equals to 2.262 MPa. For the max bending, the FB max is equals to FBX plus FBY. So FB max is equals to 6.625 plus 2.262. FB max therefore will be 8.887 MPa. That's all, and thank you.